Hi, I'm Bill Chapman. Thank you for watching today's long-range U.S.-focused forecast video brought to you by Nutrien Ag Solutions. This analysis is being provided for perspective only, and any decision made based upon this presentation is the sole responsibility of the person making the decision. Finally, please remember that long-range weather forecast is speculative by nature. I've been working with Eric Snodgrass for about 6 years, mostly behind the scenes, gathering data, creating maps and animations, and statistical forecasts, specifically long-range forecasts. Today I'm going to be filling in for Eric in the long-range forecast while he's out at the Farm Progress Show. And we're going to be talking mostly today about the prospects for an early freeze. This map shows the typical dates of the first freeze for each year. It's color-coded by the dates of the year, so that the blue shades are in late summer, early fall, August and September time period. The shades of green are throughout the month of October, and oranges, tans, and browns and such are any time later than November 1st. For any year, the freeze date, though, can typically be 2 to 3 weeks earlier or maybe 2 to 3 weeks later than the average date. We've heard from many of you that there are concerns about when the first freeze will occur this fall, because planting periods were delayed significantly for many growers due to the very wet spring, and crops will need all the time they can to mature properly before a freeze hits this year. So let's take a look at any factors that we know about right now that may contribute to an early freeze. This graph shows the daily high and low temperatures, and actually the temperature range, as blue bars on the graph for October of the year 2012. So if you look at the graph, typically our annual date of first freeze happens around the middle of October. This particular year, though, we had a weather event, a cold air outbreak, in early October, say around October 6th, 7th, and 8th. That dropped temperatures below freezing for one day or maybe 2 days. Now, if you look at the rest of that month, though, right after that cold air event, temperatures rose again to around climatological average areas around the middle of the month, even above average around October 20th through 25th, and then finally dropped again down in late October below freezing again. So if it weren't for this couple of cool days in early October, the date of the first freeze would be in late October, more typical of more recent years. So this really sort of sets the stage for how difficult it is to forecast an early freeze, say a month or two out, because really these events are weather events. They're just a simple strong high pressure system with clear nights, and it drops the temperatures down below freezing for a few hours. That's a hard thing to forecast a couple months ahead of time. And even if we were trying to forecast what the average temperature was for October in 2012, for example, it would have been about average, or maybe even slightly below average. So it's a difficult thing to forecast, but we're going to try to pin down some factors here that might contribute to an early freeze this year. One of the things that has us a little bit worried here is that some folks are maybe a little too comfortable with the late plant this season, because that the growing season has gotten longer in recent times. And while it's true that the growing season has gotten longer, about 2 weeks longer here in parts of Illinois, if you look at this bottom panel of this plot, you can see that the growing season length has gone from about 173 days in the early 1900s to about 187 days in the late 1990s. So over that century, we've gotten about 2 weeks longer. And in fact, parts of southern Minnesota and northern Iowa, the growing season length is close to 3 weeks longer than it was early in the century. The problem here, though, is that most of this growing season length, the change in growing season length, has come from earlier last spring freezes. So if you look at the top panel up here, in the early 1900s, roughly day 120 of the year was when we had our date of last spring freeze in the early part of the 1900s. And by the late 1990s, there's been a change of about 12 days earlier. So the last spring freeze has been happening earlier and earlier and earlier, giving us most of the change in our growing season length. And if you look at fall, though, fall it has the first fall freeze has gotten a little bit later, but it's really insignificant when you compare it to the year-to-year variability, which can vary anywhere from 20 to 30 days. The date of the first fall freeze. So this change of 2 days later is really not a lot to hang your hat on if you're looking at maybe extending this year's growing season because we got a late start. Okay, the previous example was for a specific location in Illinois, Pontiac, Illinois. So let's take a step back and get a broader look at the entire Midwest and see if this trend towards longer growing season holds up. And in fact, this figure right here, this map of the Midwest, shows the change in the annual growing season length over the last century, or from the period 1900 to 2017. So on this map, any states that are colored in oranges and the red colors have longer growing season lengths, and any maps that would be shown in purples would have shorter growing season lengths over that 117-year period. So you can see here that every state in the Midwest is colored orange, so we all have longer growing season lengths throughout that period. And if I hover over these states, you can see that the entire state of Illinois has about 9 days longer growing season length. That's the change in the growing season length is about 9 days longer over that 1900 to 2017 period. I'll go ahead and hover over all these states here. Indiana's about 8 days longer, Ohio almost 12, Michigan about a week longer, Wisconsin 9 days, Missouri 9, Iowa about 9, Minnesota 10 and a half, Kansas 11 and a half, Nebraska 8, South Dakota 12, and way up here in North Dakota, you can see as you move generally north and to the west, you get changes in growing season length that get longer and longer. So North Dakota is almost 3 weeks longer in the 2000s than it was in the early 1900s. So this idea that the change in growing season length comes primarily from changes in the spring versus changes in autumn, let's see if that idea holds up over the entire Midwest as well. We're looking at the number of days in the spring, where spring is defined as March, April, and May, the number of days where the temperature has dropped below freezing. And we're looking at the change in the number of days where the temperature has dropped below freezing at night, again from this period 1900 to 2018. So anytime that the map shows oranges and reds, we have more days that have dropped below freezing as time goes on, and if maps are shown in purple, there are fewer days as time goes on where the number of springtime minimum temperatures have dropped below freezing. So you can see in here that in springtime, most states here are negative values, maybe 1 or 2 more days where we drop below freezing in the spring for these states in the eastern part of the Midwest. But again, as you go north and to the west, you get more and more, fewer and fewer days where the temperatures have dropped below freezing at night as time goes on. So in the early part of the period, we may have had 5 days more that have dropped below freezing than, say, we do in the 2000s. The only state that sort of bucks this trend is Missouri, which is slightly more days below freezing now than they did in the past. Now let's switch over to fall. Months of September, October, and November, and the picture's quite a bit different. Some parts of it are the same, but through much of the Midwest here, there's not a lot of change in autumn as far as the number of days below freezing. So in fact, many of these states have more days, slightly more days below freezing in the later part of the period than the early part of the period. So Missouri and Iowa both have slightly more days below freezing in the later part of the period. The rest are all fairly constant. So the big picture here again is that while growing season length seems to be getting longer through the Midwest by anywhere from 1 week to 3 weeks, depending on where you live, most of the contribution to that is because of warming springtime temperatures, or at least fewer freezes than we used to have back in the 1900s. Not much of that contribution, at least in the central Midwest and the eastern Midwest, is coming from the fall. So here at Nutrien, we're looking at a forecast for an early freeze probability that's slightly above average. That's important for a couple of reasons. Again, one is that we've had a late start to the season, so we really need as much time as possible. So this is not good news for growers who got their got crops planted late this year because of the wet spring. But it's also interesting in that not many of the recent years have had an early freeze, so this will be somewhat of an anomaly if it turns out to be the case. We will give you a quick rundown on what some of our factors are that go into this. The first factor we want to look at is Arctic sea ice extent. So in the months of May through August here, we've had Arctic sea ice extent that's near record lows. This shows the gray area here has the average Arctic sea ice extent, and it usually melts off from May through August and even September, as you might expect with the warm northern hemisphere air temperatures and the strong sunlight. But recent years, and especially 2012, was the record low for Arctic sea ice. And we've been running, at least through May and June, we were below the record low. And even now we're right up near the record 2012 low Arctic sea ice. We probably won't, next week or two looks relatively cool up there, so we probably won't break this record, but we'll be either second lowest or third lowest in history of Arctic sea ice. Now, why that's important, if we look at the, remember what's going on in the Arctic is that we've got a lot of sunlight, 24 hours of sunlight, in fact, from May through July in this part of the world. And if you remove the sea ice, which is highly reflective of that sunlight, you've got an open ocean up there which absorbs a lot of this energy. So that energy gets absorbed for 24 hours a day, and it sits up there, and it will eventually get re-released into the atmosphere. So if we look at where we are right now, here's a picture of showing Alaska, Canada, North America, Russia, Greenland here, which for now is not a state of the United States. And we've got in white shows where we have Arctic sea ice conditions as of about a week ago, and the orange line here is where it normally is. So we've got quite a lot less Arctic sea ice than what is average, and that means that these open ocean areas right in here are absorbing, and have been for a couple of months, a lot of solar energy. Okay, so what's going to happen through time is that we're going to have, over the next couple of months, as things start to refreeze, they'll start to refreeze over here by the Soviet Union, because these waters here near Russia are very shallow, and they cool off relatively quickly as the sun starts to set in northern latitudes. And we'll get snowfall over Siberia, and we'll get snowfall over northwestern Canada. So this whole area in blue will be cold. Okay? The problem is all that solar energy that was absorbed in this part of the ocean will keep the area north of Alaska and the Bering Strait area relatively warm. And by warm, we mean 33, 34 degrees Fahrenheit, while temperatures in the colder areas will probably be, in the 10 to 20 degrees Fahrenheit range. So a good 20-degree difference, typically, between these two areas. And you may know that it's typical for jet streams to follow these gradients of temperatures. So if we've got a strong contrast in temperatures for this warm area around Alaska and the Bering Strait area, and the cold area in the Arctic and places that have refreezed and had snowfall, Well, we're going to get a jet stream more typically that will be found along this gradient. It's not always going to be there, but it will preferentially form along this area, which means we're going to have a ridge that bulges up into the Arctic and then drops down a trough into northwestern North America, and that trough will bring winds straight over this snow-covered Arctic areas of Canada. And that snow-covered Arctic air over Canada will have cooled, and this will happen sometime in late September and early October, right about the time we're worried about an early freeze. So the tendency then is for setups to happen where we get winds that come from the northwest bringing in cold air down into the Midwestern United States. In fact, there was a modeling study done a few years back here now, or maybe about 10 years back now, where a model was set up and typical weather patterns for the year 2007 were run about 40 times. And 20 of those times we just kept sea ice at what it would normally be in at that time of year, average sea ice conditions. The other 20 times the model was run where we removed a large chunk of sea ice in this very region we've been talking about, north of Alaska, north of the Bering Strait. And the model was run from, say, May through around November, the end of November. And what happened is illustrated in these two figures here. The one on the left shows air temperatures, or the changes in air temperatures from when sea ice was removed compared to when sea ice was left as average. And again, so you get this warming effect where there's open ocean that absorbed a lot of heat during the months of June, July, and August, and that warm air sits around and stays and causes a ridge to form and a trough to the east of it, down around the Midwest and the eastern part of the U.S. And on average, the temperatures were cooler in years following times when the sea ice had been removed from that part of the Arctic. So, what really happened in 2012? Well, the last time we had a sea ice minimum about like we do now, if we look at October 2012, the temperature anomalies, in fact, this is what we had. A picture that shows very warm temperatures over the Arctic as that ice can't freeze yet because it absorbed, the ocean had absorbed a lot of the summer sunlight, and a ridge forms there and drops a trough into the into North America, and especially northeast parts of North America, and we get colder temperatures again in northwestern Canada all the way down into the Midwest in our growing areas. So 2012 was the last time we had a record minimum of Arctic sea ice, and in fact at that time, the subsequent October, 2 or 3 months later, we did have this ridge form that went into the Arctic and brought a subsequent trough down into North America. The pattern of air temperatures over the last 30 days looks remarkably similar to what we're expecting over the next 2 or 3 months here. In fact, so if you look north of Alaska and over eastern Siberia, there had been a ridge forming along, coincident with the reduction of sea ice in the Arctic up here, and then a trough that brings colder air down into northwestern Canada and all the way down into the Midwestern U.S. The thinking is if this pattern persists into late September, early October, that will really increase the prospects of an early freeze. Now moving on to factor 2 here, we're currently in a solar minimum, it's called, and solar activity can be measured by the number of sunspots that are visible on the sun. And if you look at this plot showing the number of sunspots, we're really low compared to, say, the last 4, 5, 6 years. And we're at the sunspot cycles generally go in about an 11-year cycle here. And we're approaching the minimum, or right in the minimum of one of these cycles. So what does that have to do with weather? Well, it turns out there's a pretty loose relationship between sunspot cycles, and especially minimum of sunspot cycles, and a negative North Atlantic oscillation, which is just one of the major circulation drivers of the Northern Hemisphere weather. So if we look at North Atlantic oscillation, in fact, we've been sitting since early May We've been sitting in mostly negative, the negative phase of the North Atlantic Oscillation through all summer. And this is typical. It's not a really robust relationship, but more often than not, we have seen that we are in the negative phase of the North Atlantic Oscillation when we're at these so-called solar minima. And that has been the case for this summer, and probably most likely will continue on for at least a few more months. Now, what does that mean for weather around here? Well, here's a plot. If we take all the years that have had negative North Atlantic oscillations and we plot the October temperatures, surface air temperatures for those years. So these are all the years that are listed down below here, all the years with negative North Atlantic oscillations. And what do the temperatures look like in October? Well, again, they're cooler over much of, especially the eastern part of the growing areas here. So this is another contributing. It's not really robust, neither is the sea ice one, but there are at least two factors that seem to be pointing towards an early frost this year. So again, we're going to just say, we put the odds at a little better than even that we might have an early frost. And the reason that's important is that hasn't happened a lot in recent years. And we're looking at these severe sea ice losses in the Arctic this summer, and also the low solar activity and the possibility of a negative phase of the NAO persisting through October, and thus giving us maybe more chances of a ridge developing to our west and bringing some cold air down across northern parts of Canada and into the Midwest. And if one of those happens to line up with late September, early October, we could get an early freeze or an early frost in 2019. We at Nutrien Ag Solutions hope you look forward to the next long-range forecast discussion. Have a great week and talk to you soon. Thank you.